Hello everybody. Tonight's flipped homework is going to be a continuation of our real-world practice, and we're going to go back and forth between discussing slope-intercept form and point-slope form and arriving at the requested information. So depending on what we're asked for, that will determine the approach we take. So let's get right into it. It says recall the slope phrase, and I'm just going to get my, hold on, sorry, I need to get this working. Recall the slope phrase m equals change in y divided by change in x, or and y per each every x. So y per x, y each x. So per, each, or every were those three key vocab words that we looked for when we were reading to identify slope. So we have change in y divided by change in x. That really more ties to skills and graphing. When we're reading a real world scenario, we want to look for those keywords per, each, and every. So let's get right into this first set of practice. It says a linear function that models data is described. Find the slope and y-intercept of each model and describe what the slope and y-intercept mean in terms of the real-world context. So if I look at number 1, it says the linear function f of x equals 55.7x plus 60.1 models the number of smartphones sold in the United States, f of x, in millions, x years after 2006. So let's see, I have the function. And above it, I can help myself out. I know that f of x is the same as y equals, and I see 55.7x. Well, that's mx plus b. So this is nice because the model I was given right here was actually already set up for me in slope-intercept form. So if I can correctly recognize it as y equals mx plus b, I know that the slope will be 55.7. and the y-intercept will be 60.1. But if you notice, the directions said not only to identify, to find it, but also describe what the slope and y-intercept means in terms of the real-world context. So to do that, off to the side, I am going to need to define my variables. So x equals number of years after 2006, and then f of x is, let's see, number of smartphones sold, and notice it specifies, or sorry, in US, but it specifies in millions. So I know from my slope calculating days, it's y divided by x. So this is going to be 55.7 million smartphones, because that's what the y value represents, divided by per year. And just to emphasize how I knew what label went where, I know that slope is y divided by x. So once I had my variables defined off to the side, I knew how to set up that label. And then for y-intercept, this is 60.1. If I were to write this as an ordered pair, that would be 0, 60.1. So off to the side, let's kind of break down what this would mean if I were to put some labels on these values. I know that x is years after 2006. So 0 years, think about that, 0 years after 2006 means 2006. And 60.1 is the number of smartphones sold in the US in millions. So 60.1 million smartphones. So the initial amount, the initial value or number of smartphones that were sold in 2006 was 60.1 million. So notice the power of really paying attention to how you define your variables, because there was no math here. This was truly identify the y-intercept as an ordered pair, 0, comma, 60.1, and then ask myself, what does 0 represent and what does 60.1 represent? All coming back to making sure you define those variables. I'm going to leave number 2 for our next class, and number 3 also, and I'm going to pause this real quick. And I'm back. Sorry for the interruption. So we just finished number 1. Numbers 2 and 3 will be part of the bell ringer for our next class. And I'm going to look at this next set of questions. It says, for each of the following situations, identify the slope, y-intercept, and state whether the function is increasing, decreasing, or neither, and write the equation in y equals mx plus b form. So we have a pretty big to-do list, but notice there's kind of like a guide for filling out all the work. So you open a new bank account with $50 in it. Each month, you deposit $10 into the account. You want to find an equation for the amount of money in your account as a function of time. So again, the key language for M, per, each, every. And to look for the B value, we're looking for an initial value, an initial amount. So when I read, you open this account and it's got $50 in it. So that tells me that my initial amount of money is 50. And then I see here, each month, you deposit $10. So that's going to be my rate of change, my slope. If you're depositing money, it means that your account is going to have more and more money. It's increasing. So to deposit means you're adding money. And then putting it together for y equals mx plus b, m is 10, so y equals 10x plus 50. And we're all done. Let's look at number, we just did number 4. Let's do number 6. It says you start 4 meters away from the motion detector and do not move. What is your distance from the motion detector? So you start 4 meters. So right away I know B is 4. But notice it says you do not move. So do you have any rate of change? If you don't move, you're not going anywhere. So the slope here is going to be 0. My rate of change is 0. You're not going anywhere. So it's not increasing, it's not decreasing, neither. You're standing still. I don't know why it keeps doing that, sorry. To write the equation, y equals mx plus b becomes 0x plus 4, which you really could just write y equals 4, and that would be a horizontal line through 4 on the y-axis. 5 we'll leave for part of our starting practice next class. Looking at our next real-world question, before we even read number 7, let's talk about this strategy at the top. It says, when writing equations in the real world, always ask yourself, do I have the b value, the initial amount? If not, then you must first write your equation in point-slope form. That's the whole y minus y1 equals m times x minus x1, using the slope found between 2 points. So let's see if we can apply this strategy to number 7. This is a real-world scenario that comes from the National Oceanic and Atmospheric Administration. That's the source of the data. It says, our planet has been heating up for more than a century. Many experts have concluded that the increase in the amount of carbon dioxide in the atmosphere has been at least partly responsible for the increase in global surface temperature. The bar graph in figure 2.32a shows the average global temperature for selected years from 1900 through 2009. So here's the bar graph it's talking about, 1900 to 2009. The data are displayed as a set of 4 points in the scatter plot in figure 2.32b. So if we notice, we have these four ordered pairs plotted based on the bar graph data on the left. Also shown on the scatter plot over here is a line that passes through or near the 4 points. That's called, in mathematics, a line of best fit. So we're saying this is not a linear growth. This is not exact, which is why these points clearly can't all be on one straight line. But we can draw a line of best fit, a line that, to the best of its ability, goes through or near as many of the points as possible. And then it finally says, linear functions are useful for modeling data that falls on or near a line. And then part A, our question is, use the scatter plot. So before we talk about A, did anybody notice how really all of this right here was kind of just setting up the scenario for us? So don't be intimidated when you see a lot of writing. It's just helping us to understand what is this data all about. So nothing to be worried about, just calmly read it through. And now that we understand what this is all about, we can start answering some mathematical questions about the data. It says, use the scatter plot in figure 2.32b to find a function in the form. So notice, it says t of x equals mx plus b. In my brain, I automatically see y equals mx plus b. It means the same thing. That models average global temperature, T of x, in degrees Fahrenheit, X years after 1900. So off to the side, the very first thing I'm going to do is keep track of those variables. X equals number of years after 1900, and T of x equals global temperature in degrees Fahrenheit. So let's see. This is my goal. To get to that goal, I need two pieces of information. I need m, which is the rate of change, the slope, and I need b. So let's go look at the graph and see if we can get either of those pieces of information. Because nothing here said per each or every for me to get that value for m from what was written. Now on this graph, I see I have two ordered pairs, which is great. So I can calculate m. Let's do that. I'm just going to make a note of what these ordered pairs are. So 0, 56.58 and 109, 57.99. And calculating slope is a prior knowledge skill. So if you could press pause on your video right now and actually calculate that slope by yourself, I'll just help you out in case you need the formula. Change in y divided by change in x equals y2 minus y1 divided by x2 minus x1. So press pause, you calculate the rate of change, and I will, and then we will compare our answers. So using your calculator, make sure you take it out. We are going to be doing in the numerator 57.99 minus 56.58 all divided by 109 minus 0. So let's see, 57.99 minus 56.58, I get 1.41 divided by 109 minus 0 is 109 equals, let's see, 1.41 divided by 109 gets me 0.013 if I were to round this to 3 decimal places. In terms of what it means, if I go back, I see that in the numerator it was about the y values. And because I defined my variables, I know what that means. So the label for y is degrees Fahrenheit per year. So the temperature is increasing at an average rate of 0.013 degrees Fahrenheit per year. And I know that might seem like a really small amount, but if you think about what you're talking about here, you're talking about the temperature of the whole planet, right? Go back up and read what we're talking about. Look, average global temperature. So that's a big deal. That's why scientists are really worried about what's happening with the temperature. Okay, we've got our value for M. We just calculated the slope. Now we need to ask ourselves about B. And this is where that strategy at the top can really help us out. Notice it said, when writing equations, ask yourself, do I have the B value, the initial amount? Well, that is always going to be in the form of 0, comma, a number. And if I look at my graph, notice this ordered pair says 0, comma, 56.58. So I actually have that value. That is the value for B, because it's 0, comma, a number. So I actually don't have to do any work. I'm going to come down here and say B given by graph. $56.58, which is great. So there's B. So now writing y equals mx plus b, or let's do the t of x, because that's what we're supposed to use. T of x equals mx, so 0.013x, plus b, which is 56.58. Now, let's say you didn't realize the graph gave you the y-intercept. You technically could use this value for m and one of these two ordered pairs in point-slope form, and you would get the exact same answer. But that's a whole lot of unnecessary work if we know what the graph gave us. So just to emphasize this point, always check before you start plugging into point-slope form right away, because the graph or the information might actually give you the initial value automatically. So always check for that. We have a couple follow-up questions here. It says, if the trend shown by the data continues, use your model from part A to project the average global temperature in 2050. Well, my 0 year is 1900. So before I can plug anything in, I need to subtract. So I need to do 2050 minus 1900, and you might need to use your calculator, or you can use mental math. If you need to use your calculator, use it, okay? Because there's no problem with needing to do that. The problem would be if you're just kind of watching without trying it yourself. So 2050 minus 1900 gets you, can you see it? Nope, I'm trying. There you go, 150. So this means the value for x, the input, is 150. So T of 150 equals 0.013 times 50. Wherever I see x, I'm plugging in 50, plus 56.58. And let's see, let's do it in the calculator. 0.013 times 50 plus 56.58. And we get 57.23 degrees Fahrenheit. So the projected global temperature in the year 2050 using this model is projected to be 57.23 degrees Fahrenheit. And if we look at the initial value, right, so back in 1900, we've increased from 56.58 to 57.23, which again, on a global scale, is definitely a big deal. Number 8, I will leave for us to discuss in class. If you would like to give that one a shot, that would be great. I would like to touch base on number 9 about cars to wrap up our flipped notes for this evening. Number 9 says, the line graph in figure 2.28 shows the average fuel efficiency, so how efficient the car uses gasoline, in miles per gallon. Ooh, notice miles per gallon. There's that key Y per X language of new U.S. passenger cars from selected years from 1955 straight through to 2009. And we'll start right away by defining variables. I could either look at the x-axis. Oops. Okay, let me back that up. So it's not miles and gallons. Average fuel efficiency. So I was quick to say that. Miles per gallon is actually the y value. See that? And x is given to be the years. So x is number of years. Since 1955. Or you could just say number of years. It's up to you. If you say since 1955, you're going to have to do a lot of subtraction. So for right now, we'll just say years. And then f of x, or the y value, represents, it says on the y-axis, average fuel efficiency. And that's being measured in miles per gallon. Alright, the very first question says, find the slope of the steepest line segment and describe what this slope represents. So we need to go to the graph and actually make a decision on what piece we're going to look at. It says steepest, so let's see. No. Oh, check it out. Right here is definitely the steepest, where the steepest part happened. And then it kind of flattens out a little bit. So this is not one from here to here. It's definitely steep. But it's between these two segments right here that it's the steepest. And that is connected to this ordered pair and this ordered pair, based on where these balloons are pointing. This one is right here and right here. So that's how I know the two ordered pairs I need are 1975, 15.1, and 1980, 22.6. So now that I have my ordered pairs, nothing holds me back from using what I know to calculate slope and answer this question. So we're going to do m equals change in y divided by change in x equals y2 minus y1 divided by x2 minus x1. And if you could press pause, that would be awesome. And you finish finding the slope on yours, and I will find the slope here, and we'll compare answers. So press pause, please. I'm going to write 22.6 minus 15.1 in the numerator, and 1980 minus 1975 in the denominator. So we have 22.6 minus 15.1 is 7.5 divided by 1980. If you can use mental math, that's great, but I'm going to pretend like I'm not so sure. Use calculator, no problem with that. 1980 minus 1975 and get 5. So this means there was a change in what? What divided by what? Well, I see that my y value is in the numerator, and I see that y is the miles per gallon. So I know 7.5 miles per gallon per 5 years. But I don't want to know per 5 years. We want to go one more step to find per year. 7.5 divided by 5, and we get 1.5 miles per gallon per year. And if I were to write that as a sentence, fuel efficiency at its steepest, I'm just taking the language of the question and turning it into an answer, increased at a rate of 1.5 miles per gallon per year between our years 1975 and 1980. And if you look, we've got other parts here, B and C, and we will pick this up in tomorrow as part of our practice. But if I've gotten you started and you have a couple of minutes to keep trying the other parts or any of the other ones that we left for in-class discussion, that would be fantastic, because then you come to class with some great ideas to share. Have an awesome rest of your night, and any questions, don't hesitate to send me a reminder.